somehow in the same package that your CPU is going on, because that's going to be a real pig to cool. Now, in the consumer space, and for a lightweight and notebook with adequate 3D capability, a converged chip like that certainly makes sense. And if AMD can make that a differentiator that helps helps price and gives a good experience, great. But my belief it's not ready for a workstation space at this time.
That's our conclusion as well.
Okay. All right, so you've seen most of my demos. I have 2 more things to run for you. Are we doing good time?
Thank you.
Okay, good. Any other questions at this point? I'm going to talk about benchmarking. There are many benchmarks out there. The ones I'm going to focus on are the ones from SPEC, Standard Performance Evaluation Corporation, which some of you are certainly familiar with. I know, David, you are. Does anybody use these in their lab?
My reviewer does.
Right. The number of magazines who will publish spec results for workstations that we send along. Right. So I have a special relationship with spec. There are 2 committees that produce benchmarks that are workstation centric. There is, let me illustrate this with demos. There is spec GPC, which produces ViewPerf, and I'm HP rep on the ViewPerf committee. In fact, the pretty splash screen that comes up at the beginning and the pretty web page you get at the end with the results, I designed those. That's my claim to fame. I didn't do the rest of the programming. But the artwork I can do. And then over here, the other class of applications that we get from spec are the APC applications, benchmarks, which are application performance characterization. So GPC is graphics performance, and that committee generates ViewPerf. And spec APC produces a suite of applications that run on top of a suite of benchmarks which run on top of workstation applications. This one is the benchmark for MuSec Lightwave 9.6. And I am the chair of spec APC, so if you've got any questions about these benchmarks, please feel free to ask, because I am intimately involved with them. We meet 4 times a year around the table, and the members of these spec committees are HP and Dell and Fujitsu, so we for short keep each other honest, AMD, Intel and NVIDIA. So all the relevant workstation vendors are all around the table in this co-opetition type of dynamic. So here in the Workstation Business Unit, we do a lot of benchmarking. Let me explain why. Whenever Intel or NVIDIA or AMD come up with a new product or a new generation of products, or even a fan out of different products in the generation, we need to understand how they perform relative to each other. Right? Gigahertz has not changed over all these years, so in the next generation of CPUs, probably a very similar range of frequency bins that we have now. But everyone would expect more performance. So we need to quantify that and verify that when we get these new components, that our customers will see a performance benefit when we roll to new workstations. Another one is graphics cards. For example, FX 380, FX 580, FX 1800, FX 3800. Can I look a customer in the eye and say, if you buy a more expensive graphics card, you will get better performance? Well, we can't do that unless we measure it, right? And it turns out for many applications the answer is no. Other applications the answer is you bet. You see? So understanding this whole performance profile thing is interesting. Furthermore, here's another thing. The components we use in our workstations come mainly from Intel, right? The CPUs and the chipset and so on. And memory is a standard commodity, and pretty much everything is from the same parts bin as our competitors get their parts. You know, we offer the same CPUs generally, and so on. How can we get a performance advantage where an HP workstation will outperform a competing workstation with the same components in? Well, there's a number of answers, but the most important one is the BIOS work that happens here in the labs. So with what the BIOS engineers do is they take all the, when Intel delivers a CPU, there's this stack of documentation that says, here are all the switches and levers and dials that you can turn on this CPU. It comes with all these controls attached. Obvious ones are Intel hyperthreading on or off. That's an obvious one. Okay. What about turbo boost? You're familiar with that, where individual cores will essentially overclock themselves dynamically if there's power available. Well, the heuristics that govern when that happens is something that you can influence from the BIOS. Power saving states, when cores kind of go bye-byes for a few minutes, or a few milliseconds because there's no work to do, right? Saves some joules, which is cool, but maybe it takes a little while for it to re-wake up when more work comes. So in some applications, you can actually really hit the performance just by being too aggressive about going to sleep. Well, so the BIOS engineers give you a switch to control, at a rather granular level, exactly what's going on in there. So there are all these different parameters from the BIOS that go into the processors and other subsystems. Memory access, how to alleviate the effects of non-uniform memory architecture, all these things. And that's where our BIOS engineers are focused on performance, and why we need to benchmark to see if they got it right. Because they can do theoretical stuff. Sure, my memory now goes this way, this way, this way, this way. It should be better. But we don't know until we actually run it through benchmarks like this. So that's why we do all this benchmarking. It's a key activity that happens here.
Yeah, and Dan brings up a good point that I couldn't show you in the lab. I don't know how to show you. The fact that we invest in BIOS uniquely inside of HP. We don't use a third-party BIOS. So some companies can choose to use a variety of commercially available BIOSes that are supported by Intel and AMD, etc. We choose not to. We invest in BIOS, and so we have that ability, as Dan described, is that we can understand, okay, where are the performance bottlenecks? We work with the ISVs. We work with the graphics suppliers. We work with Intel. We understand, okay, how it all works. Then we look at what are called the theoretical possibilities. Then we test and validate those, and we have the benchmarks then to actually validate that. So it's a wonderful, integrated group. It's almost symbiotic in terms of their interfaces, in terms of how they look at it, from the hardware engineers on the EE side to all the drivers, and then the applications themselves.
Right, exactly. And the BIOS team is interested, and the architectural team, and marketing, right? Because everybody uses benchmarks for marketing, because if we get great results, we want to put them out there. Plus the product managers who are responsible for each platform want a good handle on my new workstation is faster than my old workstation by this much for Pro or mechanical CAD. So it's a very useful set of metrics that's used throughout the organization. So that's benchmarking. Any other questions? So that pretty much wraps up my talk on performance. You can certainly quiz me over lunch. I'll be there eating alongside you, so any questions you've got, for sure. And I can certainly give you some advice on how you would go about benchmarking your workstation meaningfully. Because there are benchmarks out there that are just not very meaningful for workstations that actually a lot of people use. Because they're designed for just a desktop PC, and they don't flex the muscle of workstations in a way that would allow a workstation to differentiate itself from an ordinary desktop PC. So the spec benchmarks are useful in that respect, and some others. There's Opus for Pro Engineer, and there's Cat Bench and other things in different spaces.
I have a question about spec.
Yes.
It's been a while since I've run ViewPerf, but the last time I ran it, I believe it maxed out at 4 processes, concurrent processes.
Oh, okay.
Is there a way to increase that? Because with some of the new Z800s and stuff, when I would run it, it would only be testing 4 of the cores.
Yeah. So that was with ViewPerf 10.
Mm-hmm.
ViewPerf 10 allowed you to run single thread, which was essentially one window of ViewPerf going on, 2 threads or 4, and we capped it at that. And part of the reason is that going for more and more threads does not actually help you much, because everything is still bottlenecking through the same GPU,
Mm-hmm.
right? And it's not a very true-to-life way of running an application anyway. So with ViewPerf 11, we actually pulled that out. So ViewPerf 11, unless you know how to dig in and find the hidden switches, it doesn't offer you that multi-thread operation anymore.
So it's just single thread?
Yeah. Which makes sense, right? Because all of these applications that are traced In other words, the way ViewPerf works